So we get now to an application of the concept of networks. This one is the first half of us looking at kind of activities and jobs that need to be done and keeping a chain of prerequisites in such a way that we can work out which path is the most important, which ones can be left to be done slightly later, and which things need to be done as quickly as possible so that a job can be complete and finished in the most efficient manner. So for today, we're mostly just going to be looking at making these kind of activity tables into a form of graph. And next lesson, we will actually then try and analyze these graphs. So an activity table is one of these tables like we have here, which is a bunch of tasks that need to be done. We'll normally label them with some sort of letter, how long they take, and do they need something else to be finished first. So something simple that my son can do is he can cook those boiled or semi-boiled eggs that you dip bits of toast into, which he and his younger brother quite enjoy. And so the first thing you have to do is boil water in the saucepan. That takes a couple of minutes until it's boiling because you can't put the eggs in until the water is at a set temperature, or you won't be able to know that the eggs have cooked properly. Also, you can't leave them too long or they will go hard boiled, and that's not going to work. So task B, the cooking of eggs, has to wait until after the water is boiling. As well as that, you need to make the toast and cut it up, but that doesn't take quite as long as the eggs. And you then serve things, but only when the eggs are cooked and the toast is made. Now, obviously, I've taken things out like take eggs out of saucepan, cool eggs in cold water. I've tried to simplify things down to a nice, easy one for our first example. And specifically so because there are three different ways that we can actually show this using a diagram. So the first is the idea of saying that each of these paths, so this path here is activity A and it takes 2 minutes. Now this of course is our start. Is there anything else that doesn't need a task? Well, yes, C has no prerequisite, so we could also say that C, which takes 3 minutes, is this other activity here. Now, does anything rely on A? Yes, cooking eggs relies on A and it takes quite a while. So we could draw a path in here. We could call this B, which was cook the eggs and take 6 minutes. And after B and C are both completed, we can serve the meal. Now, in a case like this is where we might use a dummy path. We could have, I guess, if we'd been sneaky, joined the dots and made C go straight to B. But I can put in a dummy path here, which says that after this is over, um, with no added time, this is a fake path, we can then do D, which is serve the meal, which takes 1 minute. And at the end there, so this is at the start, and this is at the end. Everything is done and finished. So that's one of the methods we can use to draw one of these diagrams. And just before I move on, I will just add a little, you don't have to write this on here, but I would better explain because I'm remembering that we haven't actually looked at these yet, but a dummy path in a network is something we only really use when we are doing these activity style where there's a flow of things that have to happen. Because D can't start until the end of B and C, but we didn't draw B and C so they connected at the same point, this dummy path is used just to show that D does rely on both B, and by kind of the prerequisite of the dummy effect, it also has to have C. Um, Dummy paths tend to be used. What they're for is we actually don't ever want to have something like this where A and B both connect to the same point at the end. So we actually need to have kind of an A and a B. This is a bad thing. You can have A, like, oh, I'll get to that in a second, A and B, and you can use a dummy path to then put the next one in. That's running out of space on the screen. you are totally also allowed to have an A and a B and then have C and D both come back together or something like that. That's fine, but they don't like having two paths kind of parallel to each other like this. All right, so now I've just rubbed some things out, moved that example down the bottom because that's one of the methods, and I said there were three. Another way to do this, which I find is probably the most clunky of the lot, is we have the start here, and what we do is we say that the next node is A. Now I find this a bit strange because boiling water takes 2 minutes, but what we do is we show that it takes 2 minutes before we can get to A. From the start, it takes 3 minutes until we've finished making the toast, which is C. And after A, well, I might try and do this one without the dummy path because we know there's something that starts from B and C, which is kind of how we need it. Actually, this one will definitely need a dummy path. It says that B, to get to B, we need to have A done, and we need to have another 6 minutes. And again, we need a dummy path. And technically, it doesn't matter if you dot it in going this way, from B to C or from C to B. Obviously, we can see this is longer, so I'm going to go in the more logical way and say we'll go this way. But after B and C are done, we then need another 1 minute to get to D. Now, I find this really clunky, and this is kind of finished. The mixing up of kind of distances and nodes and things, it might work for you, and we are allowed to use any of the three methods, but I suspect this is not usually going to be one of the nicer ones. The first one I showed you is very commonly used, and the last one that I'm about to show you is also quite nice. And so our third way of doing this is to actually put, so we had one, I'll just scroll back down and show you. We had one method where all the information is on the edges. We had one where half of the information is on the edges and half is the nodes. This third one is where all the information stays on the nodes. So we have our start here. And as soon as we start, we're allowed to go to A, and A happens to take 2 minutes. We are also able, and I'll have to put flow on here, we are also able to go to C, which takes 3 minutes. At this point, we can go to B, which takes an additional 6 minutes. And here's where the advantage I find of this one is that we can then say that after B and C, we can do the serving of the meal, which only takes 1 minute. Now this I like, and this is kind of finished again. It's tricky when you've got these nodes like this. But this is nice because there is no information other than saying D can't happen till after B and C. So both of these edges get to stay in as normal. And in fact, in some versions of this, I just double checked the reference material. This 2 could actually be written on the outside with just the A in the node. But in all honesty, when there's this many versions of it, I don't think anyone's really going to care one way or the other. So we've got 3 options. It's up to you which one you want to use. I would suggest using a little bit of each because in an exam you have to be prepared for any type. But this is all we've got to do. Draw a graph based on some sort of activity. Occasionally you will also be asked to find this activity, and that is my plan for your assessment, is that you guys are actually going to be making up an activity table and drawing one of these when I get the assessment out to you. So for today, it is called exercise N 3.1 in the distance education resources.